Hey everyone, we're going to finish up this morning doing some solving of trig equations. So this should warm you up and get you ready to work on the sheet for lab today. And your lab leaders are more than willing to answer any questions that you have. Now, in class we started working on solving some linear trig equations. So we ended up with one solution within 0 to 2 pi. Sometimes we have to deal with a trig function that is raised to a power higher than 1. So in this situation, we end up having to take the square root and we end up with multiple answers. So I have 3 tangent squared x minus 1 is equal to 0. Again, we isolate the trig equation on one, or trig function on one side of the equation. So I'm going to move the 1 over. So 3 tangent squared x is equal to 1. Which means that tangent squared x is equal to 1/3. Now I want to know what tangent of x is equal to, so I need to take the square root of both sides. When you take the square root of both sides of something involving a variable, remember that you get plus and minus. So that means that tangent of x is equal to positive and negative square root of 1/3, or plus and minus 1 over the square root of 3, which is also plus and minus square root of 3 over 3. Now we have to figure out what angles make that true, so our goal is to solve for x. Now if we are looking at tangent, these are based, remember, on the unit circle. So tangent is the slope of the line that makes the angle, so square root of 3 over 3 are our pi over 6's. We have them in all 4 quadrants. So here, pi over 6, this becomes 5 pi over 6, 11 pi over 6, and 7 pi over 6. Now if I'm talking about the slope, here, tangent of x is equal to square root of 3 over 3. And it's positive. Now that's true for the whole line. So the positive ones go all the way across, and our 2 solutions for that are these 2. Now the negative ones, if we're talking about negative slope, our tangent of x is negative square root of 3 over 3 here. So that includes this whole line, and we have 2 solutions for that as well. 5 pi over 6 and 11 pi over 6. Now as far as our overall solutions, that means x is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Sometimes we also have functions that are listed in quadratic form. So we have things like cosine x times cosine x plus 1. Now remember, if you have an equation like x times x plus 1 equal to 0, and we want to figure out what x is equal to, then we set each piece equal to 0. So we get x is equal to 0, and x plus 1 is equal to 0, or x is equal to negative 1. Same thing's true with trig functions. So we can take each piece and set it equal to 0. So that means we're looking for the angles that make cosine x equal to 0, and we're looking for the angles that make cosine x plus 1 equal to 0, or cosine x equal to negative 1. Now thinking about the unit circle, cosine is our x value, so we're looking for angles that make our x value, make our cosine or our x value equal to 0, and we have one here at pi over 2, and one here at 3 pi over 2. As far as cosine of x equaling negative 1, there's only one of those, and it's here at pi. So our total solutions for this particular problem, x is equal to pi over 2, pi, and 3 pi over 2. Now this one was already in factored form, so you see that it was already factored out, cosine x times cosine x plus 1. Now they're not always given to us in factored form already. Sometimes we have to factor them. Now 2 cosine squared x plus cosine x minus 1 equals 0. If I am looking to factor that thing, most of the time for most of us it doesn't look nice and easy to factor when we have cosines or sines or tangent functions in there. So you can re-express it as a variable instead. So if I were to let u equal cosine of x, then what I really have, or what I can re-express it as, is 2u squared plus u minus 1 is equal to 0, and then I can factor it. So if I'm factoring, then I know that I have 2u and u. I know that they have to, the end pieces have to multiply together to give me negative 1. So I know I have 1 and 1. Now the arrangement of the signs is based on the middle term. I need that middle term to be positive, so I have plus 1 and minus 1. Now my factors, I can set them each equal to 0 to solve for u. So u plus 1 equals 0 gives me u is equal to negative 1. And 2u minus 1 equals 0 gives me 2u equal to 1, u is equal to a half. Now we know that u is cosine of x, so that really means I'm looking for angles that make cosine of x equal to negative 1 and cosine of x equal to a half. Back to our circle, cosine is our x value. So we found cosine of x equal to negative 1 in the previous problem, and I've got a solution of pi here. Now we need cosine of x equal to a half, so cosine equal to a half is our pi over 3 angle, and then the one in the fourth quadrant as well, 5 pi over 3. So as far as our solutions, that means that x is equal to pi over 3, pi, and 5 pi over 3. Just a couple more to make sure that we have it down. Sometimes, if I'm trying to solve a trig function, a trig equation, I don't just have x in the argument. So you notice here it says 2 cosine of 3x is equal to 1. I'm going to work through the solution in the same kind of way, except when we get to the end, we need to remember that we have 3 times x instead of just x here. So this really says 2 times cosine of some angle is equal to 1. And if I divide by 2, I get cosine of 3x is equal to a half. And we can find where cosine is equal to a half. In fact, we just did. So looking at our unit circle, remember that cosine of some angle is equal to a half, given that angle being pi over 3, or 5 pi over 3. Now, here's where things get a little bit different because I don't have just plain old x in there. Whatever that angle is, the cosine of that angle gives me pi over 3, or pi over 3 gives me cosine of 1 half, and 5 pi over 3. So what I'm going to do is take that angle and set it equal to pi over 3 and 5 pi over 3. It's not just x in there anymore, it's 3x. So that means that 3x has to equal pi over 3, and that 3x has to equal 5 pi over 3. Now our goal is always to solve for x itself, so I have to go through and divide both sides by 3 in order to figure out what x is equal to. In this case, x is equal to pi over 9, and x is equal to 5 pi over 9. One word of caution for when you do problems that have something other than just plain old x in them, at the end you do have to verify that you're still within the 0 to 2 pi domain. So these two solutions are still between 0 and 2 pi, so they're both good solutions, but sometimes you get one that is outside the domain because of this alteration of your x value. All right, last one for this morning, and then I'll let you, or this afternoon it may be, and then I'll let you get to work on your lab. I have 3 times the tangent of x over 2 plus 3 is equal to 0. So same story. We don't have just x in the argument, but I'm looking for 3 times the tangent of some angle plus 3 is equal to 0. Moving things around, that means 3 times tangent of x over 2 is equal to negative 3. Dividing through by 3, tangent of some angle is equal to negative 1. Now if I'm thinking about tangent and the 1's and negative 1's, then we're talking about our over 4 angles. So tangent is 1 or negative 1 when sine or cosine are the same. So if I need it to be negative, meaning I'm moving downward in slope, and that brings me to this particular angle and this one. So that's the same line, has the same tangent value. So this is 3 pi over 4 and 7 pi over 4. All right, now instead of just being x equal to those things, it's whatever is in the argument. So that means that x over 2 is equal to 3 pi over 4, and x over 2 is equal to 7 pi over 4. Multiplying by 2 to finish, so that means x is equal to, if I multiply both sides by 2 here, I can simplify my denominator, and I get 3 pi over 2. Same story over here. That gives me x is equal to 7 pi over 2. All right, last step in these is to verify we're still within 0 to 2 pi. So if I look at these, then 3 pi over 2 gives me something right down here. 7 pi over 2, on the other hand, if I'm talking about pi over 2's, there's 1, 2, 3, 4, 5, 6, 7. So that 7 pi over 2 solution ends up way over here, more than 1 revolution around the circle, which means I'm no longer between 0 and 2 pi. So that one is not a good solution, but this one is a good solution. So we only have 1 here. One little homework note. Check the domain on problems. We have been working mostly in class with the 0 to 2 pi domain like this, not including 2 pi. Some of the problems on your homework are from 0 to 2 pi the other way. So they look either like this, and they include both endpoints, or they look like this, and they only include the 2 pi. So that makes a difference, because if you have 0 for a solution here, you just have 0. If you have 0 for a solution in the middle one, you have 0 and 2 pi. If you have 0 for a solution in the last one, you just have 2 pi. So watch those domains on the homework problems, because just knowing this will save you some time, hassle, and frustration. All right, your lab leaders will answer any questions that you have. Feel free to email or stop by if you have any questions for me. Thanks.